Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, thank you. You're still with me today. And today we'll continue our discussion on the chapter of dynamics. And this is the third video on it. There will be about 4 videos, okay, for this chapter. Okay, so now we integrate the concept of Newton's law of motion with kinematics. So here's the problem solving strategy we need to follow. First is to identify which physical principles are involved, and then we solve the problem using strategies outlined in the text before. I mean the previous video. So let's dive into the example 4.10. What force must a soccer player exert to stop spin? So it starts from rest and exerted forward, reaching a velocity of 8 meter per second in 2.5 seconds. You're asked about the average acceleration, what the average force, if the mass is known to be 70 kilogram and the air resistance is negligible. So acceleration is very straightforward. You need the final velocity and the initial velocity, and also you have the duration. And it is, yeah, just delta v over delta t, so you get 3.2 meter per second square. Okay, and how about the force, average force? Yeah, average force is ma, so 70 times 3.2, and it is 20 oh 224 newtons. Okay, now let's discuss about the 4 basic forces. Okay, so there are only 4 distinct forces account for all known phenomena that is explained in physics. Okay, so we have uh yeah, nearly all of the forces we experience are only based due to only one basic force, which is electromagnetic force. Okay, and you see the basic force are all true to act through the exchange of microscopic carrier particles, and the characteristics of the basic forces are determined by the type of particle exchange. And action at a distance, such as the gravitational force of Earth or the Moon, is explained by the existence of a force field rather than physical contact. So the 4 basic forces that are meant are the gravitational force, the electromagnetic force, the weak nuclear force, and the strong nuclear force. Okay, weak and strong nuclear force act over an extremely short range. Okay, um, oops, yeah, you can see the approximate relative strength and the range of each of these force, and if their direction or repulsion. Also, you can see what the carrier particle that cause the forces to exist. Actually, graviton is still not invented yet, but the scientists speculate that there's a carrier particle that causes gravitational force. Okay, so the gravitational force is surprisingly weak. It is only because gravity is always attractive that we notice it all. But some scientists nowadays argue that maybe there are gravitational force that is repulsive too. Okay, physics is still developing till this day. Electromagnetic forces can be either attractive and repulsive. Okay, if they did not cancel, the electromagnetic force would completely overwhelm the gravitational force. Uh, okay, so these two forces were thought to be quite distinct until early in the 19th century, when the scientists began to discover that they are different manifestations of the same force, and this is the discovery is a classical case of the unification of forces. Okay, so they cannot be considered to be a manifestation of one force, which is called a electroweak force. Okay, now previously we are introduced with the phrase action at distance, and it means that we are discussing about concept of field. Okay, concept of field is a very important thing in physics. So all forces, okay, acts at a distance. I mean that, yeah, not all forces actually, but many of important forces act at distance. For example, gravitational force. Okay, friction, for example, is an electromagnetic force between atoms that may not actually touch. Maybe this is a little surprising, right? Because actually, when we sense a touch, actually, we are not really, uh, I mean, touch. Okay, but actually, this is an interaction of electronegative force between the atoms. Okay, what is that carries forces between objects? That one way to answer this is to imagine that a force field surrounds whatever object creates the force. That the second object or the test object is placed in the field will experience a force that is function of location other variables. Okay, so the concept of force field is also used in connection with electric charge, and it will be discussed later. Okay, you see, this is actually an interaction, okay, the exchange of masses that resulting in the repulsive forces, and this can actually explain, okay, the catch after the reaction, and this is the analogy exchange of meson between, actually this is also a particle, basic particle, between a proton and a neutron that carries the strong nuclear force between them. This is just one of the analog that to tell you how the particle exchange, okay, that we will discuss in later units, later chapters, I mean. Yeah, actually there are quite many explanations about how some forces work here. I'll not go into depth because you will not uh, have this, I think, in your senior high school exam, but you need to know a little about this. Mhm. Yeah, we are done with this and we'll go to friction. Yeah, we have discussed a little about friction before. So what's a friction? Friction is also a force, okay, that oppose relative motion between surfaces in contact. And if this is useless, no, friction is needed, and it allows us to move. Okay, so while a common force, the behavior of a friction is actually very complicated and still not completely understood. Okay, so if two surfaces are in contact and moving relative to one another, then the friction is called kinetic friction. But when an object are stationary, there are static friction that can act between them. Okay, and yeah, there are two types of friction. Okay, okay, so imagine trying to slide a heavy crate across the concrete floor. You may push harder and harder on the crate and not move at all. And this means that the static friction response to what you do, it increases to be equal to the, and in the opposite direction of your push. That if you finally push hard enough, that the crate seems to slip suddenly and start to move. And it means that you have deal with the static friction force, and you now only deal with the kinetic friction force, which is less than the static friction force. Okay, and yeah, the magnitude of the static force is Fs less than or equal mu Sn, which mu s is the coefficient of the static friction and n is the magnitude of the normal force. Okay, and Fs max equal mu Sn. And for the magnitude of the kinetic friction is Fk mu k n. Okay. Okay, so it actually self-explanatory. Into a longer explanation for you. So mu s is different from mu k, okay? The value is different. You can see this. Mu s always greater than mu k or equals to mu k in some cases. This is just explanation on biological phenomenon that related to physics. Okay, skiing exercise. A skier with a mass of 62 kilograms is sliding down a snowy slope. Find the coefficient of kinetic friction for the skier if friction is known to be 45 newtons. So you see, you have 45 newtons. So mu kn. Okay, so n from this free body diagram, you can see that n equals w cos 25 degree, and the fk is mu k n, right? And n here is mg cos 25 degree. So mu k is fk over the w cos 25 degree. So mu k is about 0.082. Okay, it is with no unit. Okay, and you can also find mu k with this formula. Fk is mg in the x direction because Fk is mu k mg cos theta and mgx is mg sin theta. So mu k is tan theta. Okay. It's actually very difficult. Friction. Yeah, so this is the friction explanation. Okay, so there are interaction, electromagnetic interaction that cause a friction. Now let's discuss a little about drag forces. Okay, so it is a kind of friction. Okay, when we move in a fluid. Okay, so we face like a resistance. Okay, that oppose the motion of us. Okay, and Ft, the drag force, is found to be proportional to the square of the speed of the object, which can be described with this formula. And the relationship is like this: C is the drag coefficient, A is the area of the object facing the fluid, and rho is the density of the fluid. Okay. Okay. At the terminal velocity, it means that, yeah, you see, uh, as the person velocity increases, the magnitude of the drag force increases until the magnitude of the drag force is equal to the gravitational force, thus producing a net force of 0. And it means there are no longer oscillation, and it reaches the terminal velocity. So F net mg minus fd ma equals 0 here, and mg equals fd, and it gives us with this v equals square root of 2 mg over rho ca. And for example, if we assume the density and also the mass, the area, and the drag coefficient with this, then we can find the v to become more or less 350 kilometer per hour. Okay, this is another example using the same formula, and it's found to be 44 meter per second. Also, the above quadratic dependence of air drag upon velocity doesn't hold if the object is very small, so we need to find the drag force using the relationship. And another relationship is called the Stokes law, which states Fs equals 6 pi r eta v. R is the radius of the object. Eta is the viscosity of the fluid, and v is object velocity. Okay. Now let's discuss a little about elasticity. Okay, so there are stress and strain. Okay, so a change of shape due to application of force is called deformation. Okay, first the object returns to its original shape when the force is removed. Then the deformation is elastic for a small deformation. Second, the size of the deformation is proportional to the force. That is, for small deformation, then the Hooke's law is obeyed, and this is the Hooke's law. F equals k delta L. Delta L is the amount of deformation produced by the force appliance F, and k is the proportionality constant. So delta L equals F over k. Tensile strength is the breaking stress that will cause permanent deformation or fracture of material. You see this curve, this graph. Here is when Hooke's law obeyed, okay, where F and delta L goes linear together, and this is a electric region with a little deformation that can come back again, and here is permanent deformation takes place, and this is fracture takes place. Okay, so change in length, tension, and compression elastic modulus. So we have what called an elastic modulus, which is Y. Okay. So experiments have shown that the change in length depends on only a few variables. Delta L is proportional to force F and depends on the substance from which the object is made. Additionally, the change in length is proportional to the original length, and firstly proportional to the cross-sectional area of the wire or the rod. And this is the formula. Delta L equals 1 over Y times F over A times L0. And this is how to calculate the length deformation by applying the formula that we have been presented before. Okay, we just need to enter the one that is already known. Yeah, this is just another explanation about the biological phenomenon that related to this physics concept appliance. Okay, let's calculate the deformation of how much does your leg shorten when you stand on it. Okay, so 70 kilogram man supports 32 kilogram of his mass on it, assuming the bone to be equivalent to a uniform rod that is 40 centimeter long and 2 centimeter radius. So 62 times 10.8, this is the weight. This is about 607.6 Newton. And a cross-sectional area, yeah, when we assume the bone to be equivalent to a uniform rod, it is pi r square. It's about one, yeah, this amount. And delta L is about 2 times 10 to minus 5 meter when we enter substitute all the things. Okay, so if we rearrange the previous equation and mix f over a to one side, it is defined as the stress. Okay, and the ratio of the change in length delta L by L0 is defined as the strain. Okay. And we have another thing, sideways stress, which is shear modulus or shear deformation, which is delta x 1 over s. This is the modulus 1 over s f over L L0. This is an example showing how this works. Yeah, I wanted to read it by yourself. Actually, it's self-explanatory. It's the same as before. This is just another application of Young modulus. Okay, I mean Hooke's law. Then if the change takes place in modulus, then we have bulk modulus. Also, it takes a similar form with the previous form. Okay, you can see it. The formula is just a little modification from before. Yeah, that's all for this unit. We have done with the unit. Okay, I want to share with you a little thing about a little quote. I mean, Yeah. So let's see. Let's see if I can. Okay. You don't always need a plan. Sometimes you just need to breathe, trust, let go, and see what happens. This is from Mandy Hill. That's the end of the video for today. Thanks for watching. Thanks for following so far. And here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-with exploits.unaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you.